Now, all what we have seen does only work for small oscillations and always uses the harmonic approximation. So we will stop our potential energy at the second term. But quite often it's not possible to stop only there. You need some more insight on the system. The problem is that in that case you won't have an analytical solution anymore. You will have to use an approximate one. So we are going to find solutions Q alpha in the form of Q alpha first plus Q alpha second, where Q alpha first is the solution of the harmonic oscillator, so it's the ideal solution, and this will be a correction. Of course, you could go on with 3, 4, 5, 6, 7. It really depends on what you need. But this is the simplest solution, a situation in which you might find yourself that you need this extra contribution. Of course, the contribution will become smaller and smaller and less important the more you go on. So our equation at this point will be of this form. Where this will be a function of q, q dot and q double dot, and will actually contain what are called combination frequencies. So frequencies that are in the form omega alpha plus or minus omega beta, and that will also contain 2 omega alpha and 0, so a constant displacement. You should have already seen this in spectroscopy, for example the overtones or this kind of things, where you find some smaller peaks that are always much smaller in intensity than the normal harmonic ones, that actually have that are actually part of a vibration with this kind of combination of vibrations. Or you could find some kind of displacement from your harmonic model, and it could come from here. So actually, how are we going in the end to find this kind of Q2 correction? It's quite easy, because you simply search it in this way. You put your unknown corrections in this part of the equation and your known harmonic solutions in this function that is the non-ideal part of your system. In this way you will find these corrections by using your ideal and known and analytically found correct solutions to the problem. So at this point our small introduction to analytical mechanics is over, and I hope it will help you in the future.